Hey, hello and welcome to today's GFG problem of the day. Hope you are doing well. So let's say today's problem. So in today's problem, we will be given a dictionary of words. Okay, a dictionary of words and a string A. Okay. Now what we want to do is we want to find out. Uh, so we want to segment A, right? Segment A in such a way such that each segmented word should be part of. We need to find out whether each segmented word is part of the dictionary B or not. Okay. So for example, when I say segment, right? So how to segment this? For example, I, right? If I segment, if I separate, right? Samsung, right? So if I separate these words out from A, okay, so these words need to be part of this dictionary B, right? We have to find out. We have to break the word A, string A in such a way such that all the broken words should be part of B. And we have to find that out. If it is possible in any way, right, then we have to return 1, else we have to return 0. Okay, else we have to return 0. So, okay, so what we'll do, what approach we'll follow, right? What approach we'll follow? So what we'll do, so we'll start with this, right? With I, for example, right? With I, we'll find out, okay, if is I part of B or not? Yes, it is part of B. So what we'll do, we will take the remaining string and in recursion, we will follow the same thing. We'll check. Now, for example, we'll send this string, the remaining string, the recursion, right? So we'll start with L now. We'll append, we'll take a temp variable and we'll check, right? We'll put this character L, right? And we'll check if L is part of this B or not. No, it is not. Then we'll take the next character I. We'll append to this temporary string, and we'll check whether Li is present or not, right? And then what we'll do, we will no, it is not present, then we'll take the next character, append the next character in the temp, and we'll check if it is part or not, right? And then what we'll do, no, it is not, if it is not part, then we'll append the next character line, right? And we'll check if it is present in B or not. Yes, it is present. So what we'll do, we'll simply take the next string and we'll pass on the remaining string into the recursion function, and we'll follow the same process again, right? We'll take a s temporary string, right? And append, we'll use s, right? We'll append s to this temporary, right? We'll check if it is part or not. Similarly, then no, if it is not, then we will keep on appending the remaining characters and we'll check, right? If, for example, now finally, if you have Samsung, right? So if it is present, yes, right? Then what we'll do, yes, for all the words, right? Segmented words, it is possible to break A, right? And okay, so we'll return 1 here. So let's quickly implement the code. First, we'll implement the Java code, then I'll show the C++ code. Okay. So for example, let's say what we'll do is now we'll take a set, right? We'll take a hash set, and what we'll do, we'll put this dictionary B into this set. Okay. So why we are doing, so that the word search will take O of 1. Okay, we'll take O of 1. So the time complexity will be reduced. Okay. So we've taken into set. Now what we'll do, we'll take a helper function. Okay. Okay. So we'll take a helper function. Help. We'll pass the first character, the index, right? 0. Okay. The index. And then what we'll pass A, the string, and set. Okay. And let's say, for example, this returns, right? 1 or 0, right? So we'll have this static int help function. We'll have this I, then string A, and set of B, right? Or let's say set. Yeah, right. So what we'll do now, we'll have a for loop in J, which will start from I, right? And which will go till A of length, right? J. Yeah. And now what we'll do, we'll have a temporary string variable, right? Let's take string builder in Java, string builder, right? So what we'll do, this is a temporary string. We are going to append each character and check, right? We're going to append each character. So temp.append a.char add, right? Append each character J, and we are going to check if it is part of dictionary or not, right? Set dot contains temp. If it is containing, then we'll pass on the remaining string. If help, right? J plus 1, right? We'll pass on the remaining string A and set. Okay, if it is returning 1, then only return 1, right? Else continue with this temporary building of the string. Okay. And if it is not possible, simply return 0. Now, what will the base condition, as is a recursive function, right? So the base condition is if we have reached the end of the string, right? We have exhausted, right? So there's no more string. There's no more. The string is over, so we'll return 1, right? That means we have coded all the string and it is possible. Okay. So now let's run this and check. Oh, it is, why it is returning? Hmm. Oh, okay. So this, we need to make it to string. Okay, as this is a temp string builder, right? So let's run now. Yes, let's submit. Yes, it is accepted. Ideally, we can, I don't know why the test cases are accepted, right? But ideally, we can optimize this further by taking this memoization, by doing memoization or by taking DP array, right? So let's take that as well. Let me show that approach as well. So what we'll simply do, we'll have a DP and we'll take the size as a maximum of A, right? Maximum of A. So the size is 110, right? So what we'll do, 1101 will take, okay. And what we'll do, we'll fill this array dot fill. I think it's arrays dot fill, and DP will fill with -1, right? And we'll pass this DP. Now, why we're taking this memoization? Because when we do recursion, right? When we do recursion, when we pass the right, when we pass on this the remaining strings, right? So there are chances that there will be repeated computation of the same string. Okay. So in order to avoid that, okay, let me take this. So we'll check if it is, for example, let's not write that first. So yeah, so for a particular string, right? If it is one, if it is returning one, so what we'll do, we'll simply put this into DP of I position, right? DP of I, and here as well, DP of I for that particular substring, right? If it is not possible, we'll store that, right? If it is not part of dictionary, we'll store 0, and if it is part of the dictionary, we'll store 1. Okay, and here simply we'll check if dp of I, right, is not equal to -1. That means it is already pre-computed. We have pre-computed in some previous step and return dp of I, right? So that the time complexity will be reduced drastically, right? Let's run this. Oh, now, okay, no problem. So let's add dp here as well. Okay, let's submit this. Yes, the solution is accepted as expected. Okay, so let's quickly see the C++ code as well. I have already implemented that. It's almost same. So here, if you see, we have this unordered set. We are inserting into the set, right? Each dictionary word, and we are having DP array here, right? And this is the helper function. It's almost same. We are checking here if it is -1. If it is not -1, return DP of I. And we are having this string as a temporary string. We are printing each character, right? And we are checking if it is part of set. If it is part of set, then pass on the remaining string to the helper function and follow the same process, right? And here we are storing the DP of I and returning. Similarly, we are doing the same thing. And here is the base condition. Okay. So yes, so this is a solution. I hope you've got the solution. Please subscribe to my channel, like the video. Have a happy, healthy, and a great day. Thank you so much.